So in this short video, we want to talk about what are the differences between automation types out there. And the first one we want to look at is actually controller itself. So when we look at something like Nexus Dashboard, CAT Center, NDFC, all these controllers perform a specific task in the network, and they automate some elements of that structure. So if you look at something like Nexus Dashboard, you might define itself a subnet, and you say, carve up this particular subnet to create all the subnets that are needed between for underlay links or a VXLAN API and Fabric. That's automation. That is a specific automation. Now that is tied with a graphical user interface that provides you with the ability to go ahead and make changes, which is manual, but still in that automation, if you look at it, it would say, hey, I need to add this network to these 10 leaves, and automatically would go in and do that work for you. The next type of automation is task automation, which is the most common type of automation that we have today. Here's where a network operator writes some form of code or changes the data structure for a particular type of automation orchestration system in such a way to allow a task to happen. So they might say, hey, I need to add a specific amount of BRFs or VLANs or ports to the network. And they might define that instead of playbooks like Ansible playbooks to go ahead and say, we need to create these BRFs, these VLANs, etc. All this stuff gets added in. Those elements are taken in that context, executed, and it completes. And that automation just literally went through that task. It says step 1, step 2, step 3, step 4, 5, and it pushed everything onto the network as it was defined in that automation structure. But infrastructure as code takes a different approach. In infrastructure as code, we look at things from a declarative configuration point of view. And what we mean by this is that inside of some sort of source code repository is a representation of the network configuration as a whole. Everything. And that network configuration, what we're doing is making modifications to that structure of the network representation configuration. So if you were to look at a file, there's a file and it has 25 BRFs and you're adding 5 more, then you would just simply add 5 more BRFs to the declarative configuration. And then the change in the code of that is what triggers the overall execution of change in the network. But that gives you in itself a complete view of what the network looks like inside of this code structure. Okay, let's do a comparison of infrastructure as code automation against task automation in some important areas. First one to think about is going to be how it is approached overall. And infrastructure as code allows the operators to just focus on what it needs to be changed in the network instead of how it needs to be changed, which is very different when task automation, because in task, if you're doing procedurals, you're looking at it from the perspective of that network operator also need to build code structure or code logic to perform the action. So this might involve taking an Ansible playbook and defining the logic of how the Ansible playbook is going to execute to apply those changes. The second part is when we look at standards. Due to the centralized nature of infrastructure as code, that means that any changes performed against the data structure itself is picked up by automation and executed against the network. And the task automation is different because different operators potentially might take a different approach in regards to how they built the code base to perform the action. In an infrastructure as code capability, then due to its nature and the way that its centralized code repositories exist, it builds itself inside of a collaborative use space. And finally, we look at validation, which in infrastructure as code is embedded inside of the pipeline, allowing all the operators to always have some form of structured testing occurring before and after code changes are pushed to the network. And this is much more elusive inside of the world of task automation, as it would require the engineers to also create the testing code that would run and verify that the changes were done correctly. And usually those happen by some sort of visual cues, and those might miss, in the end, potential errors or mistakes.